Okay, so we're looking at, this is Intro to Polynomials, page 10. How does the food industry set prices? The food industry is made up of a collective, that doesn't make any sense. A collection. The food industry is made up of a collection of diverse businesses that together make the majority of the food consumed by the world's population. How do these businesses decide which items to advertise and how much to charge for each product? Number one, what types of food or drink do you see advertised often?
Subway. A hamburger.
So fast food.
I always get that Subway ad on Snapchat.
What do you mean by hamburger?
I thought that you meant that we're advertising on most menus.
Oh, no. If you see an advertisement for a product.
Oh, Coca-Cola.
So let's just go soft drinks,
Doritos. Yeah.
snacks / chips,
Gatorade. Don't get those sports ads.
sports drinks. These are the ones we see ads for often. Okay, pretty good job. What do you never see an ad for?
Probably calculators.
Food.
Oh.
Food. Water. Aquafina.
Do they have commercials?
I don't ever see them. What did you never see ads for?
Probably tomato soup.
There are tomato soup ads. It used to be
I have soup on
what's the
Do you see them often?
what's the old Giants running back?
He says never.
Saquon. He did Campbell's, because before him was Jerome Bettis, the bust. I don't even know him when he played for the Steelers. They have actually soup ads, so I'm gonna X Campbell soup, even though that's not a bad guess.
Tuna sandwich.
Yeah, a tuna sandwich. Okay. I love those bread commercials that they have.
Why did they not advertise
Yeah, that's what we're fixing to discuss.
that? Wait, milk.
I love those milk commercials that I see all the time.
Oh, those egg.
Those egg commercials, farm fresh eggs.
What about the cheese commercials?
There are a few cheese, but you're right, not much. But I have seen a cheese commercial too. There used to be when I was a kid.
The little circle red cheese. Yeah. The thing about the circle one was the cows and those.
Okay. Yeah. So why do you think we see ads for the things we do see ads for, and we don't see ads for the things?
Because stuff like bread and milk, they sell itself because people need it. People need that. People really don't need fast food or soft drinks or snacks or chips.
That's it. That's correct. That you don't need to advertise for things that people have to buy anyways. Right? I mean, it's not as much competition. Whereas you have to convince somebody they need soft drinks or the new explosive Doritos. I mean, whatever they call them, explodes in your mouth. Whoa, stupid stuff like that. So, that's exactly correct. So, questions there. 2, the lines below model the possible relationship between the price and the number of customers for 2 popular supermarket purchases, baby formula and soft drinks. So, when we're reading a table like this or a graph, let's make sure we know what the axes represent. So the x-axis here represents the price, and the y-axis represents the customers in millions. So just general notices when you look at this. What do you notice about these graphs? This is not, you don't have to be super mathy right here. You can just interpret the data.
Formulas more expensive.
People buy more soft
Okay, that's a better answer. Where'd you come up with formulas? What do you mean by that?
It goes up to 120, and soft drink only goes to 50.
Well, soft drinks could go to any of these prices, too. That's the thing is, so like, if I charge $20 for either one, this is the number of customers for formula, and here, $20, this is my number of customers for soft drinks. So, what Jay said, let's focus on that, and then let's see if we can change yours, because you're onto something, but you're not exactly interpreting it correctly. Jay said more people buy soft drinks. That's true as long as I'm charging less than $50, right?
People will pay more for formula.
That's a better interpretation. Is that even if the price of formula goes higher, it still has a market. People will still purchase it. Where Jay's, his would have better been said, the general market for soft drinks is much higher than the market for formula. There are way more people who are willing to buy soft drinks. Because we're giving away for free here, right? And still only a little over 80 million wanted formula. Whereas over 240 million wanted soft drinks. So those are some good notices that the market for soft drinks is a larger market. But what Jack Riley was saying, people are willing to pay more for formula. So I'm going to try something different here. See if I can do this. That's not going to work. Oh, it did work. Oh my gosh. That's poorly worded. Let's see if I can. I like my first sentence. Okay, forget this. I was trying something different. Here, save us time. You guys have an answer already? Did you type what we said? Or write? I guess you didn't type. Here's what we're supposed to say. I don't want to write it all again. The market for soft drinks is larger, but the people are willing to pay more for formula. And then what's something you wonder? That could be anything. All right, there's no right or wrong. I normally skip those because they said here they wonder how companies figure out this kind of data. How do companies figure out this kind of data?
Well, I mean, it's probably obvious. Who's buying a Coke for $50?
Well, we don't know. We don't quite know what that means. It could be like a case of Cokes. Like, so we don't know enough information. Nobody's going to buy a 2 liter for $50, I don't think. But, well, an addict might. If you're a soft drink addict, just the same with people who vape or dip or drink alcohol. No matter how high they make those prices, there's still going to be people that do it if they're addicted bad enough. Right, so there could be people like that for soft drinks. I mean, I'm with you. I wouldn't pay that much for one, but I wouldn't pay that much for almost anything. Okay. B, which customer base formula or soft drinks, is more swayed by an increase in price? Soft drinks. How do you know?
Because it's a steeper decline.
That's good. They said, here's their answer. Again, doesn't have to be exactly theirs. They said soft drink consumers are more likely to decrease consumption or stop buying when the price increases. It says the slope is steeper. There's exactly what we're talking about. Slope is steeper, so the change in customers per price increase is higher. You guys want me to take a picture of that answer? I don't really want to write all that out. I'll put it on there, just in case somebody's watching the video back. Watching my video back. I record every lesson, post it.
Wait, can they hear me right now?
Yes. Let's just go to a new slide. The way those are tied together. That'll be easier. Let's look at 3. Look at the data in the table below. Calculate a company's revenue for each item when the price is $10 and when the price is $45. So if the price was $10 and there were 200 million people that wanted to drink soft drinks, 2,000 million? Well, there's another way we write that normally. What's crazy is I'm looking at what they wrote. They wrote 2,000 million. So never mind. Let's just go with 2,000 million.
No way.
I promise that's what they wrote. Yeah, that would be 2 billion is what I call that. But if we want to go 2,000 million, that's fine. I should have looked down before I told you. No, well, that's not how we say that. All right, what about, this one's going to sound a little nicer. 78 million people want formula for $10. That's going to be 780 million. And let's increase the price up to $45. So if it was $45, the number of soft drink customers drops to 30 million customers. So what would be their revenue? How much money would they be bringing in? Maybe 1.35 billion.
1.35 billion.
So just to keep it looking the same, that would be $1,350 million. So the amount of money brought in by soft drinks did what? It decreased when I charged more. Let's look up the revenue created by charging more for formula.
2,340 million.
Or 2.34 billion. So that's interesting. So the formula companies, are they maximizing their profits?
No.
What about soft drink companies? Or do you think they're trying to maximize profits?
Yes.
Okay. So do you think it's a good idea for food companies to always charge more? Should the formula people be trying to maximize their profits? Should they make formula more expensive? Why? Why?
To make more money.
Okay. So you're speaking as a CEO for the formula company. You're speaking, you said no, who are you speaking for?
The mothers.
Yeah. The people who have to buy formula every day. So if you price people out of formula, that's probably not a good thing to price people out of. The mom who can't afford to buy the formula, that's not a good look. You price people out of going to Disney World, that's fine, right? But you price somebody out of formula, that's a different story. So they said if you overcharge, you will lose so many customers, you end up making less money. Right? That's what happened with soft drinks. The soft drinks, even though they charged more, they made less money. Right? And some foods are necessary for survival, so we want to keep those reasonably priced for mankind. Right? The graph below gives the food company's revenue for baby formula. The x-axis represents the price of the formula. Label the y-axis revenue in millions and the x-axis price. So here the y-axis represents revenue, and that's in millions. So that's how much money they're bringing in. And the x-axis represents the price of the formula. So as we go left to right, what can we say is happening?
It's a little.
Well, let's just talk about the x value. What's happening as I go from left to right?
It increases.
What is? Don't say it. Give me context.
Pricing.
The price of the formula is increasing. So what happens as the price of the formula increases?
Revenue goes up.
So initially, as the price increases, the revenue also increases until it reaches a max revenue close to $60 in cost, right? And then as the price increases over $60, the revenue decreases. Okay? So let's label some key points here. Okay? So this portion of the graph here that I have in green, we would say that R is increasing, or the revenue is increasing during that portion. Can you guys read that? Not really. It's okay, let's just deal with it. That's all I'm saying. So then from here down, as my Y's decrease, we could say that the revenue R is decreasing. We've kind of already talked about it, but this point here, what can we call this point? It is the vertex, right, is the official math term. What does that represent?
Maximum.
Max what?
Max revenue.
It's the maximum revenue. Okay, and this whole time, the one thing that I've realized that we do a poor job of teaching up to this point is, like, when I look at this chart, I view it very much like a timeline. I'm reading it from left to right and seeing what's happening as we go. So like here, as I read this from left to right, I talked about it at the very beginning, right? This is as the price is increasing. It's what's happening. So I get a different story depending on what I increase the price to be. And two more points that are important here are the x-intercepts. All right, we could label that. We could say that R of P is 0. What's another way to say R of P? We're saying the revenue, right, would be R of P. The Y value is 0. Yeah, what you got, Kim?
I have a question.
Yep.
Never mind. I don't have a question.
So what do these two x-intercepts represent? Like, give me context.
When
Where,
no one is buying it.
that's not true.
But
When they're making no money.
That's correct. That's correct.
Because, I mean, trillion people buying it, and they still wouldn't.
That's correct. There's nothing in my chart that says anything about number of consumers, right? It's all about revenue. So right here, if they charge nothing, they're bringing no money in. They have no revenue. And vice versa, if they charge $118, whatever this is, they're not making any money. Nobody's buying either one at $118. Okay? Questions about any of that? Let's look at 5 then. Does each equal increase in price change the revenue by a constant amount? Why or why not?
No.
It does not. How do you know it does not?
Because
It doesn't have a rock.
Yeah. So how could I say that? It does have an A rock. It doesn't have a constant A rock.
it doesn't have a slope.
And so, well, again, I could find a slope. I like what you guys are saying. You're on the right track, but you're not saying it the correct way. I could find a slope between any 2 points.
It's not linear.
It's not linear. That's what you're trying to say. You're trying to say a little more fancy than what you needed there. It's not linear. So every equal price increase, every equal change in the X does not produce equal change in the Y. Right? That was our big fancy definition. So they say, here's their wording, no, the graph is not linear. Then they give an example. They say increasing the price from $0 to $10 increased the revenue by $800 million. So think again what we talked about yesterday. That's a change in the X by 10. It produced a change in the Y by 800 million. So if it's linear, if I find another change by 10 that doesn't change it by 800 million, then I know it's not linear. So we could just pick any other interval that has a gap of 10. They just picked from 10 to 20. It didn't have to be 10 to 20, but increasing from 10 to 20, how much did the revenue go up when I went from 10 to 20? $600 million. So you see how I've got an equal change in the input does not produce an equal change in the output. Not linear. Okay, that's a way you can prove that. Even if I didn't have the graph. 6A. The new intern at the company suggests selling the formula for $20. Is this the best price? How do you know?
It is not the best price.
Not the best price. How do you know?
Because it's not at the max revenue.
Not the best. That's right. So should I charge more or less at $20? So because if I charge a little more, I could make more. Another intern, this must be Tweedledee and Tweedledum. Another intern says, I think $80 would be the right price to charge. Is that the best price?
No.
Fire the interns. How do you know?
Because they're charging too much.
Correct. Because if you charge less, you could make more. So see, if the goal was to make the most money, what is the optimal price of the formula? It's fine. They say roughly 60, but it's all, I mean, if you're anywhere and you say approximately, about, around, and you pick anything in that ballpark, you're okay. And how do we know this?
Revenue is maxed.
Revenue is maxed. Another way we could say that, we could say it's at its peak.
Revenue is increasing.
Yeah, you could use that. 7. At what price will the company make no money on formula?
108, 116, 0.
So if they charged either $116, let's say roughly $116, or $0. And then we kind of already talked about this. Why? Why do they make no money when they charge $0?
Because they're not bringing in any money.
Right, because they're giving it away for free. Right, so even if a lot of people are taking the product, they're still not making any money. And why are they not making any money at $116?
Nobody's buying it.
Yeah, nobody's buying it, right? So you got different stories that are going on with each x-intercept, right? Even though you look at the graph, you think, well, it's the same thing's happening. They're not making any money, but there's different reasons behind why they wouldn't make the money. So again, that interpreting and understanding what's going on. So at $0, it's free. At $116, nobody buys. So when or why might companies use factors besides revenue to determine their price? So if you're the formula company, why might you not charge $58?
Because maybe some people cannot afford it.
That's right. And like I said, we'd already kind of talked about that. So for items like baby formula, maximizing revenue might not be the best because then families couldn't afford it. And there are serious consequences if a family couldn't afford it. So let's just say for essentials, it's not always.
They just made water $1 million per gallon.
It would be the same thing here. Some people can afford $1 million.
I don't think many people can.
Yeah, then people would find a different way to.
People would crash out and start drinking mud puddles.
You would exactly.
People would
You go
collect
drink.
rainwater. People would, like, what if you just look down, your water bill is $4.8 billion?
Yeah. I'd build a pond in the backyard probably. Be probably cheaper.
And then you just get one of them straws for like 35 cents. Yeah, the ones you can drink.
I had one of those new times. My grandpa.
You just drink one.
Okay, so I need to talk a little bit more about this graph, and then we'll be done. So we said that this point, let's find the coordinates for the max point very quickly. We said it was $58, right? That's what we went with. So let's say 58 is the x value. What would you say the y value is?
No.
Yeah, that's fine. We'll keep it nice and simple. Let's say 2,500. We know it's more than 2,400, right? We don't know exact.
Like 24 aces.
So we would say this. R was increasing. If I ask you, where is R increasing? Yep. Or ask for the interval on which R is increasing. What would you say?
0 to 58.
That's correct. Because we read increasing or decreasing like a timeline, right? I said we want to read from left to right. Don't say it's increasing from 0 to 2,500, right? Because it did go from 0 to 2,500, then it decreased from 25 to 0. So I'm giving the same values twice, which doesn't make any sense. So we want to keep it in that function. We know because it's a function, each x has only one y, so let's talk about it in terms of the x's. So when we ask about increasing or decreasing, read it like a timeline, left to right. So R is increasing from 0 to 58. So I'm using interval notation. We talked about that already, didn't we? The parentheses versus inequality symbols. So, increasing, decreasing. Should 58 be included with a bracket or excluded with a parenthesis? At 58, is it increasing?
I think not. Correct. It should
It's
be
not,
parentheses.
it's not increasing because
Yeah, parentheses.
It should be a parenthesis. That's correct. Remember when we talked about tangent lines?
yes.
If I were to draw a tangent line at the vertex, what would that tangent line look like at the vertex? It would be a
It would go just
horizontal. All lines are straight. But I know what you're saying. It would be a horizontal line, right? From left to right. So what's the slope of a horizontal line?
0.
0. Which means it's not increasing or decreasing at that point. And then as soon as we start heading down the hill, we can see my tangent lines now have negative slope. So it's decreasing.
What's the tangent line of, what's the slope of the vertical line? Is it?
Undefined.
Could be infinite.
But that's, I mean, in some instances that's what it is. It's just undefined is the way we talk about that. So it's increasing from 0 to 58. And where's R decreasing?
58 to 116.
It's decreasing from 58 to 116. All right, and one more question I have for you, and we're done. How do you find x-intercepts? If it just in general, like I know right here we could look at the table, and we could find the x-intercepts. But what if I gave you an equation? How could you find the x-intercepts from an equation? Everybody knows what x-intercepts are across the x-axis. How could I find x-intercepts?
Whenever the y is 0.
That's it. The x-intercept always happens when the y value is 0. So if I'm given an equation, and I want to know where do the x-intercepts happen, we could set the y value to 0. And then we could solve. Right now I just have a single unknown. Okay with that? So that's how you always find x-intercepts. To find x-intercepts, plug in 0 for y. How do you find y-intercepts?
So the x is 0?
Yeah, plug in 0 for x. If you plug in 0 for x, you get an ordered pair, right? X is 0, y is some value. That's the y-intercept.
So our y-intercepts right here would be 0 and 116.
The x-intercepts.
Yes.
Yes. X-intercepts would be 0 and 116. Our y-intercept would be 0. Almost everything we'll work with will only have one y-intercept. Because what would happen if we had two y-intercepts?
It would be like this.
If we had multiple y-intercepts,
It wouldn't be a function.
it wouldn't be a function. And everything we like to do in math, we like for it to be a function. Every input has one output. So we could have multiple x-intercepts. But most of the time we'll only have one y-intercept. Okay? Very good.